The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to day two of our four-part webinar series. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. Looking at the handout section of the GoToWebinar panel, please note also that a PDF copy of today's presentation is available for reference. With that, we will go ahead and turn things over to Ron Eck. Hey, Ron.
Good morning, Mike. Thank you very much. Good morning, everyone. Welcome back for day two. Just a quick overview of Tuesday. We talked about kind of an introduction. We looked at characteristics of pedestrians and bicyclists, and then we talked about some design issues. We'll talk, as you can see here, a little bit more about design today from the cross-section standpoint. We'll look at sidewalks. We'll talk about intersections, and which include crossings, crosswalks, roundabouts, and then we'll wrap up with overpasses and underpasses. So that's our agenda for today. Looking at cross-section elements, which of course relates to the width and the elements such as the traveled way, the shoulders, sidewalks, that sort of thing. One of the big things to consider when it comes to cross-section is lane width. As it says here, narrow lanes can improve comfort and safety for vulnerable users by promoting slower vehicular speeds. And also, by narrowing lanes, we can create space for maybe a separated bike lane, a widened sidewalk with a buffer, reduce crossing distances, and those sorts of things. I think I talked yesterday a little bit about flexibility, and the Green Book does allow significant flexibility when it comes to lane width. They talk about a range between 9 feet, in a low speed sort of maybe urban street context where you don't have significant commercial vehicle traffic, all the way up to 12 feet, which would be appropriate, of course, say for a freeway, those types of higher speed controlled access facilities. NACDO has the Urban Street Design Guide, which talks about having lane widths of 10 feet as appropriate in urban areas, and these can have a positive effect on safety without impacting traffic operations. They do note that for designated truck or transit routes, one travel lane that's 11 feet wide may be used in each direction. What about shoulders? Shoulders are obviously important for a number of reasons to roadways and roadway operation and safety and maintenance even. But sufficiently wide shoulders can also improve bicyclist safety and comfort, especially on higher speed, higher volume roadways. And we talk about, to accommodate bicyclists, a 4-foot wide or greater paved shoulder width, continuous along the length of the roadway and through intersections, should be provided. Where you have barriers like guardrail or curb or something like that, 5 feet would probably be the appropriate minimum width. And consider shoulders if vehicle speeds are greater than 50 miles per hour. Another question that comes up is when to pave shoulders. The AASHTO Green Book presents some policies on shoulder width for specific roadway functional classes and recommends that usable shoulders on arterials be paved. And designers, I think, should consider paved shoulders to accommodate bicyclists and possibly even pedestrians in rural areas. And here we see an example from Mississippi, a rural area essentially, but notice the bicyclists are operating on a paved shoulder. What about shoulders and different project types? It's important, I think, to capture opportunities to include or upgrade paved shoulders during all types of roadway projects. Obviously, we need to weigh the trade-offs such as safety benefits for all users, construction costs, cost savings over the life of the roadway. And I'm going to share some examples of shoulders and shoulder widths during different types of roadway projects. We'll look first at resurfacing and restoration projects. This gives us an opportunity to reallocate roadway space, and in some cases, think about reducing the lane width to maybe provide more paved shoulder width that would be suitable for bicycling. The AASHTO Bicycle Guide suggests the following. Foot travel lane and a 2-foot shoulder. A bicycle-friendly configuration on that same overall width of 14 feet would be maybe a 10 to 11-foot travel lane and then a 3 to 4-foot shoulder to make that shoulder suitable for bicycle travel. On rehabilitation projects, the project type here includes complete replacement of the pavement, so that gives us opportunities to add paved shoulders as mainline pavements are replaced. Also, maybe a good time to widen narrow paved shoulders, especially if rumble strips are being added. What about reconstruction and new construction? We include paved shoulders on these types of projects. It can be cost effective and should be considered on both rural and suburban arterial projects. Also a time to consider other treatments like separated bike lanes, shared use paths, sidewalks for the non-motorized users. And of course, these may be more desirable in urban and suburban locations where you have higher bicyclist and pedestrian demand. Issue that comes up with bicycles and roadways is edgeline rumble strips. Of course, these are tactile patterns, usually milled off the roadway or other reasons. But a lot of these designs are difficult for bicycles to traverse and can actually make the shoulder unusable for bicyclists, because the rumble strip, depending on the design, can cause the bike to kind of shudder violently and result in a loss of control, which obviously is serious from the operator's standpoint. So there's been a lot of discussion and research over the years on the issue of edgeline rumble strips, which from a motor vehicle safety roadway departure standpoint have been demonstrated to be a cost-effective safety measure. But the point is we also need to be alert to their effect on bicycles. The AASHTO Bike Guide recommends a minimum 4-foot clear space from the rumble strip to the outside edge of the paved shoulder, or again 5 feet if it's adjacent to a curb or a guardrail or some other obstacle. And consider these to provide additional shoulder width for bicyclists. And one thing I always get confused myself, but let me get my cursor here. when they talk about rumble strip length, that's kind of what I would consider the width. It's sort of how, like, is it a 10-inch rumble strip or 8-inch rumble strip in terms of its width laterally along the roadway, but that's what they call the rumble strip length. And here's a couple, or three, I guess, configurations. The first one, notice the rumble strip essentially takes up the whole, almost the whole 2-foot wide shoulder. So that's what they mean by rumble strip length. From this edge of the rumble to here is called the length of the rumble strip. So this is what, maybe a foot or so, or maybe even more. But clearly that's undesirable from a bicycling standpoint. It makes the shoulder unusable. In the middle, you see what they call an adequate cross section, and this also shows the rumble stripe configuration. Notice we have more narrow rumble strips. These might be like 6 inches maybe, and the edge line is painted over the rumble strips, and that's what's called a rumble stripe. But notice now we have the full, they're showing 4 feet or greater here. The full shoulder width essentially is available for bicycle use. And then the bottom image shows a constrained cross section. Notice here the rumble strip is essentially at the back of the shoulder. So 4 foot or greater, I guess, shoulder, but at least we're leaving some space here between the edge line and the rumble strip for bicyclists. And I did want to mention, maybe before we leave this, and maybe some of you are using this or have seen it, but there is a lot of interest these days, I think more from a road user, motor vehicle user standpoint than bicyclists, but it obviously can have an effect on bicyclists, on what they call I guess the jargon term is skinny rumbles. This would be a skinny rumble, maybe 4 inches or 6 inches in width. And I'm aware around the country there is some research going on at some state DOTs and perhaps even other agencies that are evaluating the safety and other impacts of these narrower or skinny rumbles. With regard to rumble strips, the AASHTO Bicycle Guide recommends providing 12 to 15 foot long gaps in the rumble strips, spaced every 40 to 60 feet or so, to allow bicycles to enter or exit the shoulder as needed. Another thing to consider, some agencies are using what they call bicycle tolerable rumble strips. The milling is not as deep as a conventional rumble strip, so they're said to be more bicycle tolerable than the conventional design. And here you see an example. Notice this gap, 12 to 15 foot gap, probably spaced every, say, roughly 50 feet or so, to allow the bicyclist to move from the shoulder to the traveled way, or vice versa. They can go from the traveled way to the shoulder. But this would be a practice to avoid. Notice, what is that, maybe a 3 foot wide shoulder, perhaps 4 feet, 3.5 or so. But notice the rumble strip is essentially, not quite, but more or less down the middle of the shoulder. And so it makes it essentially not usable by bicyclists. Maybe they could have put the rumble strip at the back of shoulder here, or maybe a rumble stripe type design under the edge line could have freed up the shoulder for bicycle use. There has been some research done on rumble strip placement, especially with regarding crash reduction that may relate to bicycles and operation of bicycles. A number of years ago, Federal Highway Administration conducted some research on this, and they concluded that for rural 2-lane roadways, there's no relationship between longitudinal rumble strip placement and crash reduction. Meaning basically the rumble strip could be at the edge line or on the shoulder or at the back of the shoulder, and the roadway crash situation or crash reduction would not be affected. Placement according to the AASHTO criteria, remember at least 4 feet of usable paved shoulder between the rumble strip and the edge of the paved shoulder, has the least negative impact on bicyclists. If you can't provide at least 4 feet of pavement, rumble strip placed at the edge of the paved shoulder and narrowed if necessary will allow most of that paved shoulder to be usable by bicyclists immediately adjacent to the travel lane. And I showed you a graphic example of that. And then I mentioned also the bicycle tolerable rumble strips. They're about, 3/8 of an inch deep and as narrow as 6 to 8 inches, may provide adequate sound to alert drivers, as well as leaving more space for the bicycles to operate, especially if they're placed under the edgeline pavement marking, the so-called rumble stripes. And as I mentioned, there is some research underway right now around the country on these narrow or skinny rumble strips, and I hope it's including the impact on bicycles as well. What about pedestrian use of shoulders? Unless it's expressly prohibited, for example, like in most interstates, pedestrians can legally walk on roadway shoulders. And although it's not maybe an intended user, most roadway shoulders can accommodate occasional pedestrian use. I would note, though, that if a shoulder is intended for use as a pedestrian access route, the PAR under PROAG, then it must meet the ADA requirements for pedestrian walkways to the maximum extent feasible. But notice this is an exception rather than the rule. Most paved shoulders are not part of an agency's PAR, the pedestrian access route. But if they are, and I'm aware around the country, I'm aware of a few locations, then that shoulder needs to meet the ADA requirements for the PAR. Just kind of a personal note, I've seen it once or twice in my travels. I probably would not mark a shoulder for pedestrian use if it doesn't comply with the PAR criteria, with the PROAG criteria. Another issue with using the shoulder as part of the PAR, if you'll allow me to back up here, maybe to this image. And I imagine the rumble strip's not here, and that maybe we have pedestrians walking on the shoulder. A concern that I would have with considering designating this, say, as the PAR, is that this edge line is not, this white edge line, even if it's thermal or paint, it's not detectable under the cane tip of a visually impaired traveler. And so that's one of the issues. It would be easy for a blind pedestrian to sort of veer out into the traveled way because there's no detectable edge to the shoulder, at least on the motor vehicle side. So that's just something I wanted to mention. But generally, shoulders are not part of the PAR.
Hey, Ron.
Yeah.
Hey, just wanted to mention from the past few slides, there's a few comments from the audience. I've copied those into the chat.
Okay, let me take a look at those. James says, seems like we're also wasting the space by not giving car drivers that auditory feedback until they get to the very edge of the pavement. Yeah, I would agree with that, although as that FHWA research found, at least on 2-lane rural roadways, it really doesn't matter where the rumble strip is placed on the shoulder, which I found that to be interesting. And Doug says, gives more recovery room for drivers. Yeah, exactly. So I appreciate those comments.
Hey, Ron.
Sidewalk. Yes, sir.
Oh, sorry. Let me copy one in for you right now. This is from Nathan.
for a rumble stripe, can thermo still be used? If not, are these more subject to wearing? I would say generally, probably thermo cannot be used with a rumble stripe. It would be paint. And actually, there's one of the benefits of the rumble stripe is because there's some paint on the milled area, that it is not subject to traffic wear, nor is it subject to snowplow damage. And so that is one of the touted benefits of the rumble stripe with paint, is that you still, what's on the surface of the pavement certainly probably will wear off, but you still have paint in that milled area that's protected from traffic and snowplow blades. And so the visibility lasts longer, I guess we'd say, compared to a standard or a normal painted line. Good question. I wanted to talk just briefly about sidewalks and associated environments. Here we see, I guess this is Pennsylvania Avenue in Washington, D.C. So a lot of pedestrian traffic, tourist traffic as well. But it shows, to me, a good example of a sidewalk. It has a wide travel area for pedestrians, so it would comply with the PROAG requirements. Also looks like it has a fairly wide buffer or furniture zone, and you can see the street trees and pedestrian scale lighting and benches and kiosks and other things. And then on the away from the curb on the other side of the sidewalk, you can see, it looks like interesting shop windows and storefronts and things, which make an attractive pedestrian environment. So sidewalks are important. I've just mentioned that. They enhance connectivity, promote walking, and are an important part of, especially in the business district or retail district, are an important part of the community and economic development for that matter. Maybe some of you have seen this depiction of the sidewalk, the so-called sidewalk zone depiction. Notice at the street here, we have a curb zone, maybe 8 to 12 inches wide. Then moving away from the street, we have a furniture zone or buffer strip, which I mentioned there on Pennsylvania Avenue. Then we have the pedestrian zone. And then in urbanized areas, we have the frontage zone to recognize that people don't walk right up against a storefront or something like that. There's some shy distance, but also the frontage zone allows for, as you see here, door openings. And sometimes people ask me, Ron, does PROAG require a furniture zone? And the answer is no. They have a number of benefits, but PROAG does not require a furniture zone. The sidewalk can be at the back of curb. But what PROAG requires is that this pedestrian zone be a minimum of 4 feet clear, unobstructed width, have a firm, stable, slip-resistant surface, and have a maximum cross slope of 2.1%. I mentioned the buffer zones, that they do have a number of advantages. The place to put street furniture separates the pedestrians from the vehicles, maybe splashing of water during rainy weather or in northern climates. That buffer zone can provide a place for snow storage, so the snow is not plowed right onto the sidewalk, and have a number of benefits. We do need to also, though, I think, be aware of some of the negative impacts. One in this one here, this scene that you see on the right, notice at least a few of these street trees seem to have become quite large, and now they represent in my opinion, a roadside fixed object obstacle that can be struck by vehicles. And of course, as everyone's probably aware too, these trees, it's hard to see evidence of it here, but as these trees reach a large size, those tree roots can and do heave up sidewalk slabs, which can affect the usability and safety of the sidewalk. So here's some guidance for trees in the buffer zone or in the recommend select arborist who can rate of growth that where you have street in terms of pruning, so we don't have protruding objects into the pedestrian access route. I also wanted to say a few words about, I call these serpentine sidewalks, and you see them from time to time around the country. I think their main reason they're used, from what I've been told, is that developers like them because they look good on Google aerial images or other aerial images if you're trying to market property or something. But if you think about it, kind of from the pedestrian standpoint and the associated considerations, I don't recommend serpentine sidewalks for in the public right of way. I think they have a place maybe in parks or interpretive areas, other sites like that where people, have the time to just sort of meander and enjoy the ambiance of wherever they are. But in the public right of way, I think people are using the sidewalk for transportation purposes. So they want to be able to get from point A to point B, as we talked about yesterday, kind of with the path of least energy. And a serpentine sidewalk, to me, doesn't provide that. But also, if you think about some other considerations, for example, ADA, think about a blind pedestrian, excuse me, who's relying on the edge of the pavement, for their shoreline to navigate. I mean, they have a really curvy route here, a lot of extra distance, maybe more difficulty in following the route. Same thing with somebody in a wheelchair. Might be difficult to take a straight line path here. They're going to often be trying to turn or adjust their alignment, which requires extra energy. But then also, I mean, just think about sort of maintenance of if you're trying to clear snow from this type of sidewalk with a skid steer or a tractor or something, or sweep the sidewalk, it would seem to make it more difficult. Also wanted to say just a few words about what we might call pedestrian level of service, meaning what are features that are significant to pedestrians, but might not be so significant for, say, motor vehicle operators who are traveling on the roadway at higher speeds. So, for example, pedestrians want good personal safety, meaning should be a reduced threat of crash or conflict with motor vehicles. But also pedestrians give consideration, I think I mentioned it yesterday, to kind of personal safety, the kind of fear of an assault or an attack on them personally as they're moving around the built environment. Also architectural interest, because pedestrians are moving at slower speed, the architecture or the appearance of aesthetics of buildings and the streetscape is important to them, maybe not so much to a motor vehicle operator who's, again, traveling down that street is much higher speed. I mentioned yesterday, pathway shade is important. Also, pedestrian scale lighting, amenities, things like benches, even street art or urban art, whatever the name of that formally is, signage, those sorts of things, even things like restrooms. Maybe that's not an amenity, maybe a necessity, but still, kind of availability of public restrooms within the walking environment or nearby. And then interestingly, the presence of other pedestrians seems to attract people. See folks out walking on the sidewalk or on a multi-use trail on a nice day, and that seems to attract other folks, generates other traffic. If you remember this, one of the first slides I showed yesterday, that street scene in a neighborhood in Seattle, Washington, that was, I think, a case, as the day went on, more and more people came out to the street and to socialize with one another and just enjoy the atmosphere. And then conditions at intersections are also important. That's where the conflicts between motor vehicles and pedestrians usually occur. Pedestrians may have to wait for extended periods to, say, cross the street. So conditions at intersections are also something that pedestrians consider or evaluate in terms of pedestrian level of service. And we'll talk about those intersections here shortly. If you're fortunate enough to have it, I advise you to take advantage of water where possible. This is downtown Portland, Oregon on the Willamette River. Obviously a very attractive scene. I realize not everybody has water of this nature, but a lot of communities have maybe a river or a stream or a pond or a lake or something like that. And you know, I think in the past in the United States, we often sort of turned our back on the water. And now, fortunately, I think people are realizing that that water is a real asset or resource, and we should sort of face the water and take advantage of it, if you will. And just interestingly, because I'll talk about it here in a few minutes, this kind of green space in Portland, I think is, I don't know the full history, but I think it's there because decades ago, there were plans to bring an interstate highway, a freeway, through downtown Portland, and maybe on this corridor here. And as I understand it, the residents and city leaders, you know, just said, no, we're going to go with more of a multimodal, you know, transit and walking and biking. And so the freeway was never built into downtown Portland and allowed them to have some space here to create a very attractive, you know, waterfront park. I mentioned considering amenities, benches here. This is, I forget where this is, but nearby there's also the urban art and other things to kind of liven up the streetscape. And then it may sound paradoxical because we're not talking about sort of walking, if you will, or biking, but another factor that makes up an attractive streetscape is just public space where folks can, you know, sit or hang out or relax. And this is also downtown Portland a few years ago. This is called Pioneer Square. It's actually a part of Pioneer Square, which actually is a whole city block that was originally occupied. They didn't apparently need that parking structure, so they tore it down and replaced it with this Pioneer Square. And this just shows kind of one corner of Pioneer Square, but based on what I said earlier, would you agree that there must be something positive about this design, because on a nice summer day, this part of Pioneer Square is filled with people. So it must be doing something right. So this is my list of kind of key characteristics of successful public spaces. And developing these is probably an art as much as a science, because I can think of, maybe some of you can think of too, I can think of some public spaces, at least in my part of the world, where they're not attractive for some reason. People don't go there, and in fact, they may become kind of a security issue. But these are some of the things to think about. Kind of like Pioneer Square, they didn't sort of develop the whole block uniformly. They have different sections or units of different appearance, different functions, if you will, that, as I say, promote social interaction. There's eyes on the street for security. Should be kind of attractive and colorful, both sun and shade, some protection from the wind. And a key thing is adjoining services and destinations. If you allow me to back up here, it's kind of hard to see, but because they have so many trees in the park here, but on the other side of the street in the background, actually on all four sides of the block, are what I would call supporting land uses. So there's things like coffee shops, restaurants, bookstores, those kinds of things where somebody can grab a beverage or grab a sandwich or grab a book and then bring it over to Pioneer Square. So having supporting land uses or destinations is another key factor of having a successful public space. So having said that, I wanted to show you an example. This is actually where I worked for many years, the West Virginia University campus in Morgantown. And I had an office on the 6th floor of the engineering building. And this was April a few years ago, mid-April, I guess. It was, I think, the first day in Morgantown that the temperature got above 70 degrees that year. So it was a nice spring day. And what caught my eye when I looked out the window, and the reason I took this photo is this was around noontime, but notice the area is devoid of any people. If you look closely, you can see a pedestrian here. And interestingly, I guess they're following the path of least resistance, because with all the sidewalks here, this person is not on the sidewalk. They're cutting the corner here through the grass, which is kind of interesting. But based on what I just told you, I thought this is an interesting contrast. Maybe this isn't such a successful public space because it doesn't seem to be attracting people at a time when I would think that it would. One reason might be the benches. I can assure you that's not very comfortable seating, especially if you wanted to sit there, say, for part of a lunch hour or something. You can see the walking paths maybe don't conform with people's desires, if you will. There are some elevation differences. You can see from the retaining walls there. So there are some areas that where you don't have sort of eyes on the street, if you will, and people may not feel comfortable. And another reason, we can't really see it here, is there is sort of a lack of supporting services in terms of like eateries or other things like that. So I just wanted to share that with you, kind of a contrast between what I would call a successful or popular public space versus another one that's maybe not so much. So any questions up to this point?
Hey, thanks, Ron. As a reminder to our audience, the questions box is available, so please feel free to type in any questions at any time. And Ron, we don't see new questions at the moment, but as they arrive, I will let you know.
Yeah, please interrupt me. Thank you, Mike.
Yep.
Well, we'll move on to intersections. Now, I realize this is an old photo, but I think it shows some of the issues that pedestrians present to pedestrians, that intersections present to pedestrians and bicyclists. Notice rather wide arterial streets. There's no refuge area in the median, so it's really a long trek for a pedestrian to cross that street, especially if you're moving slowly due to, say, your age or due to a disability. It may not be possible to cross that street before the walk sign disappears. But also notice there's probably traffic in motion pretty much at all times. In fact, interestingly, notice they just marked these two walks here, channelized slip turn lane here. They don't really want to encourage pedestrians crossing here. Directly related to the convenience store sort of combination. And notice there's driveways here. And so that's another conflict for pedestrians even trying to reach the street corner. The design guidance for intersections would be design all intersections with the assumption that pedestrians will be present. I think that's good advice. One exception, maybe some of you have been there, would be Las Vegas, Nevada. Obviously an area with a lot of pedestrian and vehicular traffic. And a few years ago, they made the decision to, at certain intersections along the Las Vegas Strip, to prohibit pedestrians at grade level and go to a grade separated system. There's elevated overpasses above ground with stairs and escalators and elevators to reach those ramps. And so notice there's really no pedestrian traffic, no crosswalks in the intersection. And I also wanted to point out, a little bit hard to see here due to the lack of contrast, but in this lower image, I think you can see they've gone to even putting in some design details here with kind of this sawtooth pattern at the top of their barriers to even try to prevent or discourage folks from jumping over the barriers. Some intersection design principles. Encourage crossing at intersection corners. Make sure pedestrians are visible to traffic. Make vehicular traffic visible to pedestrians. So it goes both ways. Drivers should see pedestrians and pedestrians need to see vehicles. Try to make pedestrian actions as predictable as possible. Minimize the time pedestrians are in the roadway. We can do that by reducing crossing distances. And then maybe use some traffic calming mechanisms like reduce lane widths or other things to try to slow vehicular traffic. Another thing that's important, I mentioned this yesterday, is improving sight distances. Sight distance to me is critical to safety, both for vehicles and for non-motorized users. So we can do things like install curb extensions, like you see here. Make sure vegetation is trimmed so that tree limbs and other vegetation are not blocking sight lines. Avoid visual clutter at the intersection. So here on the lower left, you see an example of a curb extension or bulb out. There are good sight lines, kind of a basic design, just grass at the corner. And then on the right-hand side, you see another example. And notice here, some aesthetic treatment, which is a good thing. But the thing I am concerned about here is I think that vegetation is too high, in my opinion. There could be someone in a wheelchair or a child or some small stature pedestrian walking toward that crosswalk or even waiting on the corner, and that vegetation may prevent drivers from seeing that pedestrian. So keep that in mind. I don't mean to discourage these aesthetic treatments, but I think they need to be appropriate and shouldn't interfere or block sight lines. I mentioned channelized slip turn lanes. These seem to be inherently pedestrian unfriendly, whether you're able-bodied or disabled, because if you think about this vehicle making the right turn here, given that curb radius, they can travel at fairly high speed, but the driver's attention is they're looking over their left shoulder here to check for a gap in the traffic stream they're about to merge with. So they're not really focused on looking for pedestrians or bicyclists. Notice the islands here, though, can reduce crossing distance and allow pedestrians to cross in stages like you see here. Also, we see a median island here. I would note these islands need to be curved islands so they are detectable by the visually impaired. They can't be simply painted islands.
Hey, Ron.
Yeah.
In the chat, we have a question from Dylan.
Okay, thank you, Dylan. Dylan says, is there any official guidance for paint usage when it comes to intersections and traffic calming, particularly paying attention to artistic crosswalks versus transverse lines or the continental striping? Yeah, great question. The official guidance would be the MUTCD, Manual Uniform Traffic Control Devices, which in the they do the names crosswalks or creative crosswalks or artistic streets. They have a variety of names. And I recognize there is significant interest in that, and actually a number of communities are doing things in that regard. The main concern I have with that is the visually impaired user, low vision users, who rely on contrast and colors to navigate. For them, something like the continental design would probably be the ideal crosswalk marking, if you will, because there's plenty of white material there, but there's also good contrast with the we'll call it the asphalt, street paving material. So I would say think about the visually impaired user when you're coming up with your design. And the METCD does give some guidance in terms of, I can't recall all the details, but in terms of, for example, the types of patterns and things or the surface treatments that might be used. But one thing I would recommend is get the input from the visually impaired community in terms of, if you're thinking of or the artist is thinking of a particular design, maybe get input from the visually impaired community. And that could be in one of two ways, or combination of the two. One would be to, get the input from a low vision pedestrian or several low vision pedestrians. The other thing would be to maybe get the input of an orientation and mobility specialist or an O&M specialist. This is the profession that actually does the teaching or training of the visually impaired to help them navigate the built environment. And they have, in my experience, they have a great understanding of the needs and the requirements of the visually impaired. And they can be found in many communities, and my experience has been they're more than willing to help and provide input. But that is my main concern with the kind of the artistic or creative crosswalks.
Thanks, Ron. Yeah, next question from Roger.
Roger says, when a roadway is uncurbed but walk is present, are truncated domes still required at the intersection crossing? Usually typical in residential developments that have no curbs but do have a walk. Also, Ron appears to be cutting out at times. Not sure if anyone is getting that. Yeah, I apologize for that. Maybe having some internet. Question, Roger. And we may talk about a treatment next week, but if the roadway is uncurbed and people are walking, if I'm understanding you correctly, people are walking on the sidewalk is at the same elevation as the street. Which makes it difficult for the visually impaired to navigate because they don't have their shoreline or edge on the curb side of the sidewalk. And so that is an issue. And there is a treatment, we'll talk about it next week, called directional indicators, which might be appropriate there. I don't know if you'd want to offline, Roger, I don't know, maybe email me a photo or a link to the Google coordinates that I could look at it. I maybe can give you additional details or thoughts. But maybe these directional indicators we'll talk about next week might have applicability there. And I think I mentioned most of these things. And also note that the PROAG requirements for multi-lane slip lane segments, which I believe I mentioned yesterday, apply. And they're the same as for multi-lane roundabouts, which we'll talk about here shortly. And here's an example of one of the right turn slip lane designs that has been found to be more pedestrian friendly, reduce driver speeds, vehicular speeds, and also put the crossing location at maybe a more expected location for motorists. Marked crosswalks need to be visible to the driver and the motorist. They help control pedestrian movements in the crossing maneuver, also help to promote a connected pedestrian network, and make sure that both drivers and motorists and pedestrians know where the crossing location is. Some of the design issues, where to put them, the marking types, lighting, and also maintenance. I mentioned the markings provide guidance for pedestrians, kind of defining the path, but they also alert drivers of a pedestrian crossing point, especially at roadways not controlled by traffic signals or stop signs, for example, mid-block crosswalks. And at mid-block crosswalks, crosswalk markings legally establish the crosswalk. Without the markings, it's not a legal crosswalk for a mid-block location. I think we mentioned briefly some of the crosswalk markings. We have the standard kind of parallel lines here on the upper left, the zebra pattern, if you will, a diagonal crosswalk, and then the continental crosswalk here at the bottom, which seems to be very popular. And as I mentioned, does provide enough marking material for a low vision pedestrian to navigate the street. Notice that the continental design is the only one that doesn't have the white retroreflective lines on the outside of the pattern, but that's fine. As I mentioned, this is still visible to low vision pedestrians as well as to drivers. And as I said, probably the continental and ladder designs are the most visible. Recommended crosswalk characteristics: design with the fewest possible conflict points with traffic and a short crossing distance. And the crosswalk markings should be in alignment with the connecting sidewalks. Crosswalk spacing. This is one of the issues that comes up from time to time. I determined this according to the pedestrian network, the built environment, and the observed desire lines. I think NACDO says generally if it takes more than 3 minutes to walk to a crosswalk, to wait to cross, and then to resume the journey, the pedestrian may decide to cross along a more direct, maybe unsafe or unprotected route. While this behavior depends heavily on speed and volume of traffic, it is critical to understand pedestrian crossing behaviors. Where crosswalks are marked, make sure there are compliant curb ramps at both ends. Here's a location that doesn't do what I said. Well, in several respects. Notice there is a ramp here at the bottom right. It lacks detectable warning, so it's not a compliant crosswalk in terms of PROAG, but at least it allows the mobility impaired to enter or leave the street. But here, a marked crosswalk, the other side of the street, there's no receiving curb ramp, and this is a concern to me. This is a potential civil rights liability exposure under PROAG. So if you have marked crosswalks, make sure you have compliant ramps on both ends of the crosswalk. Many of you may have raised crosswalks or speed tables where the roadway elevation is raised via a speed hump or a speed table to the elevation of the sidewalk. And here we see a couple examples. And notice, because here on this sketch, the crosswalk surface is the same elevation as the sidewalk, the curb is missing, and so we need detectable warning surfaces. They're also needed here, but I'm not sure they may be present, but I don't really see it. There would need to be detectable warning surfaces on the crosswalk, raised crosswalk shown in the photo on the left. I think I showed this image or this photograph to you yesterday. It's the no pedestrian sign. It's in the MUTCD, so it is a valid traffic control device. But the problem with this sign is that the sign alone discriminates against the visually impaired because they cannot access the information on that sign. So my advice is don't use that sign unless it's accompanied by a physical barrier, probably on the corner of the street that we don't see, where the photo was taken from, and some positive information about where pedestrians should cross the street. So they can find an alternate route or alternate path. Illumination is important in terms of visibility, drivers seeing pedestrians. Pedestrian crashes do occur disproportionately at night. There's about 4 times more risk at night in relation to crashes, even though the exposure is generally less at night because vehicular and pedestrian volumes are lower. The risk is 4 times more because of the visibility issues. And here you see illumination of a crosswalk. The Swiss report a 60% drop in nighttime crashes just by illuminating crosswalks. So it is important. And here you see, notice a well-lit crosswalk, and it's very easy for drivers to see the pedestrians crossing the roadway. Countdown signals create a more predictable crossing environment. Walk indications. PROAG requires audible and vibrotactile walk indications. The audible walk indication can be a tone or speech depending on the spacing of the push buttons. For the vibrotactile walk indication, it should be an arrow, tactile arrow on the push button unit, and that push button vibrates during the walk indication. That's the individual's cue that the walk sign is on. And this, of course, provides signal information to people with hearing impairment. And the push buttons must be located close to the crosswalk. They are used for location. Median islands. I think I've mentioned these a few times. What about some of the design details, if you will, of median islands? They reduce crossing exposure time because the pedestrian can cross one direction of travel and then wait in a refuge area before they cross the other direction of travel. And also, as you see here, it can also be sort of an asset to the community. It may add some green space or aesthetics to a location. Pedestrian refuge islands are also one of the Federal Highway Administration's proven safety countermeasures. FHWA reports a 56% reduction in pedestrian crashes where you have pedestrian refuge islands. The AASHTO Pedestrian Guide suggests considering islands where the crossing distance exceeds 60 feet. Like that old photo I showed you earlier of that intersection, those crossing distances were much more than 60 feet. That would have been a good location for some median refuge or pedestrian refuge islands. The refuge islands must be a minimum of 6 feet in the direction of travel. That's per PROAG. And if they're less than 6 feet, they're not considered a refuge area. They're considered a pass-through or a cut-through. For a refuge island, meaning 6 feet or more in the direction of pedestrian travel, there needs to be detectable warning surfaces at each end of the island. For a cut-through or pass-through, meaning the island less than 6 feet, that should be a smooth surface. Do not use detectable warnings. And something to keep in mind too, I may have mentioned this yesterday, where bicycles may be crossing. For example, where you have a shared use path crossing a roadway and you have a pedestrian refuge island in the middle of the roadway, the preferred width of the island would be 10 feet to accommodate a bicycle with a trailer. If it was a narrower, say it was a 6 foot refuge area, that trailer may be stuck out in traffic, which is clearly not a good thing. And the refuge islands per PROAG need to be at least 5 feet wide. And here are a couple islands. The one on the left is a compliant treatment that's more than 6 feet in the direction of pedestrian travel. So notice on each side of the island, we need the detectable warning surfaces. On the lower right, you see an example of what not to do. I have measured this on, this is 10 feet from one side of the island to the other, which is more than 6 feet. So there really needs to be detectable warning surfaces on each side of this island, because this would be considered a refuge area. It's more than 6 feet. Outside the scope of sort of what we're talking about here, but maybe worth mentioning, is notice the vegetation here, these shrubs. I know where this is, I won't identify it, but I've been going to this location for probably 15 years to do training. And when I first started going there, these shrubs were relatively small, maybe like a foot high or so. But over the years, you can see they've grown rather high. And now I consider these to be sight distance obstructions. Again, you could have someone in a wheelchair or a child trying to cross here, and motorists would not be able to see them due to the size of that shrubbery. So not to discourage the shrubbery, but there is a need, of course, to trim it and prune it and maintain it so it doesn't grow to become a visibility obstruction.
Hey, Ron?
Yeah.
We do have a question from Michael.
Michael says, would that non-compliant treatment be compliant if it was less than 6 feet in the direction of pedestrian travel? Yes, sir. Mike, yes, it would be. If this was, say it was 5 feet from the edge of the island here to the back edge, then we want that surface smooth, because we want the visually impaired pedestrian to think they're still in the street, and so they'll keep moving. And that's why I use the term pass through or cut through. We don't want pedestrians hanging out there if it's less than 6 feet. So everyone clear on that? Yeah, if this is, say, 4 or 5 feet in the direction of pedestrian travel, then it should be a smooth surface. But in any event, regardless of the size, I would personally recommend trimming or pruning those shrubs so we have good visibility. A flush median is not a refuge. I'm not sure how safe this family feels standing in the median there, or the two-way left turn lane, but that's certainly, in my mind, not a refuge area. And there are every year significant numbers of serious pedestrian incidents where pedestrians are in exactly this situation. They're in a two-way left turn lane, maybe on an arterial that has many more driveways, and drivers turning in or out of the driveways, they're more focused on looking for gaps in traffic and the path to the driveway or from the driveway, and they don't see the pedestrians, and pedestrians get struck. So this is not a refuge area for pedestrians. We'll look at some treatments here in a few minutes of what might be done. The AASHTO pedestrian guide addresses mid-block crossings and has some advice. They say mid-block crossings are preferred because pedestrians should not be expected to make excessive or inconvenient diversions in their travel path to cross at an intersection. But in all locations, enhanced pedestrian crossing treatments should be considered based on the number of vehicle travel lanes and the speed and volume of traffic. So they recommend enhanced crossing treatments, which we'll look at. Application of crosswalk markings. Locations controlled by signals, crosswalk markings should be installed. That's what the MUTCD says, so they're recommended. On approaches controlled by stop or yield signs, crosswalk markings should be installed where engineering judgment indicates they are needed to direct pedestrians to the proper crossing paths. And at uncontrolled approaches, like a mid-block crossing, an engineering study should be performed before a marked crosswalk is installed. So all of this is MUTCD guidance. They also say that the installation of other traffic control devices and other measures designed to reduce speeds, shorten crossing distance, enhance driver awareness of the crossing, and or to provide active warning of pedestrian presence should be considered in addition to a new marked crosswalk and signs across an uncontrolled roadway where any of the following conditions exist. And this is their list of what's that, 5 conditions. Notice the roadway has 4 or more lanes of travel without a pedestrian refuge island and an average daily traffic of 12,000 vehicles per day or more. The roadway has 4 or more lanes of travel with a raised median or refuge island and an ADT of 15,000 vehicles per day or greater. Posted speed limit is 40 miles per hour or greater. A crash study reveals that multiple threat crashes are the predominant crash type on a multi-lane approach, or when adequate visibility cannot be provided by parking prohibitions, by prohibiting on-street parking. And we'll look at that multiple threat crash here shortly. Additional crossing treatments, advanced yield or stop lines, and signing are a good countermeasure when there are concerns about the multiple threat crash. And be sure to prohibit parking between the yield or stop line and the crosswalk. And so here's the multiple threat problem, crash problem. This can occur on any multi-lane roadway. It also occurs at multi-lane roundabouts, which we'll look at shortly. But notice here's a crosswalk on a multi-lane road, 4-lane roadway, and car A here sees the pedestrian and the driver stops, which is good driver behavior. But notice in doing that, now this looks like a pickup truck screens car B, which is in the inside lane here, or in the lane by the center line, and this driver now cannot see the pedestrians, and makes it difficult maybe for the pedestrian to see the vehicle, and so the pedestrian and the driver continue moving forward, and in the worst case there may be an impact or a crash, and that's a multiple threat type crash, usually very severe type crashes. And what we're talking about with the use of the stop or yield line is to put that stop or yield line back some distance, we'll talk about that shortly, from the crosswalk. So now when car B or vehicle B is stopped here, driver B can still see the pedestrian, and the pedestrian has better visibility of the oncoming vehicle. Here's an example. The MUTCD, I think, gives a range of 20 to 50-foot setback from the crosswalk. Many agencies I'm familiar with use 30 feet. So I'd probably go along with that and maybe recommend 30-foot distance from the setback from the crosswalk. Crossing islands or crossing techniques. Here's a Photoshop version of the image I showed you earlier with the family of 3 waiting in the 2-way left turn lane. I think we probably agree this is a much better, much safer situation. I would call this for sure, this is a pedestrian refuge area. It's clearly not an area for vehicular travel. So we could use median or pedestrian islands, crosswalks, signals, and then overpasses and underpasses are all techniques to deal with crossing issues. One technique is the pedestrian hybrid beacon, or the so-called hawk signal. See an example here. I'm seeing more and more of this as I travel the country. MUTCD talks about a traffic signal or beacon warrant study. And they note it must complete an engineering study to determine if installation will improve overall safety and/or operation of the intersection. And you need to take into account both the existing as well as projected crossing demand. And Chapter 4J of the MUTCD gives some additional warrants for the pedestrian hybrid beacon. Here's some of that. The pedestrian hybrid beacon may be considered for installation to facilitate pedestrian crossings at a location that does not meet traffic signal warrants. And if used, the pedestrian hybrid beacon shall be used in conjunction with signs and pavement markings to warn and control traffic where pedestrians enter or cross a street. So that's a requirement. And also, under the MUTCD, a PHB shall only be installed at a marked crosswalk. Another crossing treatment, also seeing this more and more, is the rectangular rapid flashing beacon, the RRFB. And the MUTCD says at uncontrolled crossings where a signal or pedestrian hybrid beacon is not warranted or cost prohibitive or deemed unnecessary, consider supplementing the pedestrian bicycle warning signs with an RRFB. And I would use caution at crossings with more than 2 lanes without a refuge, meaning a pedestrian refuge in the center. Section 4L of the MUTCD addresses RRFBs. And notice they say a PED-activated RRFB may be used to provide supplemental emphasis to pedestrian, school, and trail warning signs at marked crosswalks across uncontrolled approaches. An RRFB shall only be installed to function as a warning beacon. Except as provided in Section 4L, all other provisions of the MUTCD applicable to warning beacons shall apply to RR. The warning signs, crossing warning signs with a diagonal downward arrow or an overhead mounted crossing warning sign located at a marked crosswalk. And except for crosswalks across the approach to or egress from a roundabout or free flow turn lane separated by a channelizing island, an RRFB shall not be used for crosswalks across approaches controlled controlled by yield signs, stop signs, traffic control signals, or pedestrian hybrid beacons. And also, we need to have an audible information device with the RRFBs to assist pedestrians with vision disabilities, to let them know that this is not a standard red, yellow, green traffic signal. It's a flashing warning device.
Hey, Ron?
Yeah.
Yes, we have question number 8 in the chat from Michael.
Okay, thank you. Can you please expand upon your caution about using RRFB if more than 2 lanes to cross? Yeah, that was, back up to that. That was 2 lanes without a refuge. And my main reason is I'm not sure that we have enough research yet that looks at the safety implications or the crash reduction factors for that situation. Because that would mean the pedestrian would be crossing the entire roadway, both directions of traffic, without a pedestrian refuge island. That's my main reason for saying that. I think we maybe need some more study or more data on that particular configuration.
Thanks, Ron. We do have a question number 9 from Kyle.
Okay, Kyle says, I believe the MUTCD states the RRFB PHB can be used on uncontrolled approaches to unsignalized intersections. What is the recommendation of pavement markings for far side approaches that would stop within the intersection? Yeah, good question. I will have to think about that. I will have to think about that and follow up with that. Just making a note here. Yeah, I'll have to follow up and get back on that one. Here's an example of RRFB and a crossing island. And I mentioned roundabouts. Here you see both a photo and a schematic drawing of a roundabout. I think they've been a great addition to our traffic engineering toolbox. They reduce crashes, they reduce crash severity. As you see on the right there, on the left, they can make an attractive gateway to a neighborhood, a community, a university campus. But one of the big issues is the second bullet there under design issues, is that they do create some concerns for visually impaired pedestrians, because the pedestrians cross little different location than at a conventional intersection. They're crossing one vehicle length back from the yield line and cross through a splitter island. And so PROAG, the final rule of PROAG, requires a crosswalk treatment at new multi-lane pedestrian roundabout crossings. And here we see a roundabout, multi-lane roundabout pedestrian crossing. We see a visually impaired pedestrian. And I think you can appreciate this situation poses that same multiple threat concern that we talked about earlier. So what does PROAG say about these signalization requirements for multi-lane segments of roundabouts that contain a crosswalk? They say the crosswalk treatment, a crosswalk treatment consisting of one or more of the following. So they include the traffic control signal with a pedestrian head. That's kind of the conventional traffic signal. You could use a PHB. You could use RRFB, a PED actuated RRFB, and also a raised crossing. And we talked about those earlier with respect to the channelized slip lanes. In terms of bicycles and roundabouts, bikes can negotiate the roundabout like a motor vehicle, or they can also access the sidewalk and negotiate the roundabout like a pedestrian. Maybe some of the less comfortable novice cyclists may be inclined to negotiate the roundabout in that fashion rather than being in traffic. But if you'll notice in this image here, which I showed you earlier, there is a bike lane along this approach. And notice this section of concrete here. This is providing the bicyclist with an opportunity to access the sidewalk. And that's the purpose of that. Overpasses and underpasses. Well, maybe I should back up here. And one of the issues here, and it may explain why this design looks a little, to me, a little unusual here, is that one of the issues that can happen here at these bicycle connections is that a blind pedestrian using the cane can sort of unknowingly get onto this location and this is not intended for pedestrians. So we wouldn't want to put a detectable warning surface here because we really don't want pedestrians entering the street here. So the issue is, how do you make this connection usable by bicyclists, but also to discourage the visually impaired? And this is where those directional indicators I mentioned earlier, they may have some applicability here as well. And we'll talk about those next week. Can't remember whether it's Tuesday or Thursday, but we'll talk about those. But that's another potential location for the directional indicators. Overpasses and underpasses, obviously maybe the highest cost of these crossing techniques we've talked about, but they do obviously physically separate pedestrians and motor vehicles, and so provide a high level of safety. But if you recall what I mentioned yesterday, we should have some sort of barrier at ground level, or else a more direct path for able-bodied pedestrians, because otherwise users will tend to try to continue to cross at grade. And I'm not sure what happened here, but this is a situation where this building in the background is a high school, large high school. Where I took this photograph was is a regional park, and so that's two kind of destinations that would be attractive to each other, right? You could see school students wanting to go to the park, and they did put in a grade separated structure. It doesn't appear to be ADA compliant, but it is a grade separated structure. But as I've been told, the students would get wire cutters and cut holes in the fence to try to continue crossing at grade. And disappointingly to me is the agency, rather than try to come up with a maybe more durable barrier, simply, you can see, removed a section of the chain link fence and put in a concrete sidewalk section. And so this facilitates pedestrians or students crossing this 4-lane roadway at grade. I'm worried about the safety and liability exposure there. Bridges and bridge design. Bridges come into play in several different ways. I think here in the upper left and the lower right, we see bridges that are important parts of a shared use path or multi-use trail. And you see some aspects of that design. In the lower center, you may recall yesterday when we talked about connections, I mentioned how rivers or steep topography could be a natural barrier for some long distance. And so it's important to think about ways to connect non-motorized users. And so here we see a new highway structure going in, and given the magnitude or the size of that river, there's probably not many crossings here. So I hope this structure will include accommodations for pedestrians and bikes to also cross at this location. And then the upper center this is Portland, Oregon. That's the Willamette River again. But I thought this was a neat, I guess, retrofit, you'd call it, to a structure. The bridge was already multimodal. This level here accommodates mainline railroad traffic. The upper level accommodates motor vehicles, also their light rail transit system, and also, I guess, pedestrians. But they added, you can see attached to it, a multi-use trail structure which connects kind of their riverfront trail system. And this has a warning system, because you can see it's a lift bridge. When ships are approaching and they need to raise the bridge, there's sirens and lights that flash, and there's a clearance time to allow folks that are on the structure to get off the structure. But as I understand it, this works quite well. So bridges are an important link, as I've just mentioned. And think about facilities to connect the underbridge system, transportation system, with the bridge itself. And here's what I'm talking about schematically. Notice this looks like, schematically, this maybe is a canal or a waterway, and we have a trail or greenway along that waterway. Here we have roadway crossing above. And notice it's important here to have these connections between the undercrossing and the overcrossing. And I like what they've done here. Notice they have this path for cyclists, and also hopefully it complies with PROAG so that this could be used by disabled, mobility impaired users, but also to provide a more direct path for the able-bodied. They also have several flights of stairs here. So that's a schematic. This is a little bit different situation, but here's an actual photo. Maybe some of you have been here. This is near the Hoover Dam, south of Las Vegas, Nevada. As you may be aware, a few years ago, a new bridge over the Colorado River opened up. It gives really impressive views of the Hoover Dam. So the bridge, in addition to accommodating vehicular traffic, has not only a sidewalk, but it also has a kind of a widened sidewalk where folks can view the Hoover Dam. And it actually has its own, the bridge has its own visitor center. And this is the parking lot for the visitor center. The bridge is off the photo here, out of sight. But I think you can see they went to considerable lengths, including cost, moving a lot of earth and rock, to create both an accessible path, the switchback ramp here up to the bridge, but also notice here, kind of on the left side from our perspective, are some flights of stairs so that able-bodied pedestrians can take a more direct path up to the level of the bridge. So I thought that was a good example of what I showed you kind of conceptually there in the previous sketch. And I think we talked about this already. Those switchbacks do need to meet the PROAG requirements. Also, we've been talking about stairs, but something else that comes up is maybe stairs where you don't have an alternate route, for say bicyclists. And so one way to accommodate bikes is with what are called bike channels. And here are some examples. Notice these are channels where the wheels of the bike can be moved more easily up or down the stairs. The concern with these, as this previous slide mentioned, is you don't want to create a tripping hazard for pedestrians. And also you want to make sure that the pedestrians who need it have access to handrails. Clear width when we have paths on bridge structures. Also keep in mind that, say, on a structure where you have a railing or a barrier, there's going to be a shy distance. So users, both pedestrians and bikes, will shy away from the wall or the barrier. And usually that's considered to be about 1.5 feet. So need to distinguish the actual width from the functional width and make sure the functional width provides adequate width. Desirable clear width for a sidewalk on a bridge is 8 feet. Minimum width for a one-way bike travel is 4 feet. Bridge railings, important for safety, of course. And keep in mind that bicyclists have a higher center of gravity, so the railings should be a minimum of 42 inches high. And if we have bridges that accommodate both vehicular and pedestrian and bike travel, need a crash-tested railing. And here's an example of a significant bridge structure. This is in the mid-Ohio Valley in upstate New York. Was an impressive rail crossing. The railroad abandoned the track. Fortunately, the locals were able to acquire that structure, and you can see it's been converted into a trail bridge and actually has helped the economic development of this community. Tunnels and underpasses designed for the tallest user, which is probably not the cyclist. It might be maintenance vehicles or folks on horseback. Tunnels and underpasses need to make sure we design for perception of security and have good visibility. And I think we're wrapping up just on time. That's my final slide. Any questions or concerns or anything on those last topics?
All right. Well, thanks, Ron. The questions box is open. And as always, we want to thank Ron for presenting today. We really appreciate it. And thanks, everybody, for your participation. We do have a question from Eric. What are some ways to increase the feeling of safety in a tunnel other than lighting?
Oh, great question. Well, other than lighting, I would say, from my experience with, say, undercrossings or tunnels, is obviously security, and darkness, but just things like some of them are kind of, damp or smelly, filled with litter. I would, try to, and I realize that's an expense but maybe, try to make sure you have regular kind of litter cleanup, litter removal. If there's any drainage issues, maybe try to correct those. And lighting would be a key thing, of course. Some shorter tunnels I'm aware of have, put sort of artwork on the wall, but I don't know if that improves the feeling of safety, but just trying whatever we can do to sort of make it attractive, and maybe as more people use it, that should reduce some of the negative or security related consequences with tunnels or undercrossings.
All right. Well, thanks, Ron. And looking ahead to next week, we will have day 3 of this webinar series on Tuesday, March 18th, and then day 4 on Thursday, March 20th. So we look forward to the additional sessions of this series. Thanks again, Ron. Any final comments?
No, I just want to thank everybody for participating. Thanks for the great questions that we had throughout the session, and look forward to seeing everyone again next week. And I know I've referred some questions to next week, but we will talk about those topics next week. So thanks. Have a good weekend, and we'll see everybody next week.
All right. Thanks, everybody. Have a good day. Bye.